مساء الخير يا جماعة. أنا حسين السعدي. Welcome to our fourth webinar Submerge. والنهاردة هنتكلم على Observability in Microservices. قبل ما نتكلم على Observability والmonitoring of Microservices, let's take a brief look على what does a microservice architecture look like. Basically, a microservice architecture is comprised of different services as you can see that are all interchanging. ومعظم السيرفيس دي بتتكلم مع بعض either through event buses or direct HTTP communication using REST calls. normally عندنا a list of API gateways وفوقهم reverse proxy, and these are considered edge services. Continuing على challenges اللي خالد سنباوي كان بيتكلم عليها, one of the main challenges is chaos. When talking about chaos in microservices, we're usually talking about monitoring. أو in more strictness sense بنتكلم على المنظر ده. Internal server errors أو very slow response times. Those are the main things اللي بتأفكت اليوزرز. Whether حتى إنه بتكون بنتكلم في microservice أو بنتكلم في monolith application عادية. في الآخر our customers are usually suffering performance problems, and the developer or the technical team is the last one that knows. Usually your customer knows first, which is a problem. لأن الوقت ما بين الكاستمر ما بيعرف وبعد كده احنا بنعرف بتبقى فيها ساعات مش قليلة. طيب. Moreover, one of the main challenges of microservices, generally speaking, monitoring and observing our systems, is recreating the errors. في اوقات كتيره قوي بنلاقي الكاستمرز are saying that there's a problem. However, بنخش ونجرب and we try to create the error and we simply can't find it. وفي معظم الاوقات بنقول ده غالبا كان failure علشان مشكله عند الكلاينت عنده bad internet connection او حاجه زي كده. However, sooner rather than later بنكتشف ان المشكله في الحقيقه كانت within our systems and within our network or hardware or even our applications. Since we're talking about chaos, the first or the tip of the pyramid عندنا when it comes to chaos is business monitoring. When we talk about business monitoring, احنا عايزين نعرف how our customers are using the application. Number of transactions, number of failed transactions, مين اللي عمل login والlogin بتاعته failed, كم reset password حصلت, things of that sort. Okay. Next, we need to take a look at service monitoring. Service monitoring has to do with how performant is our services, what's the health of our service. For example, لو أنا عندي service قايمة على 5 nodes، هل ال5 nodes كلهم قايمين ولا هي واحدة بس اللي قايمة والباقيين فيهم مشاكل؟ Is my service actually responding quickly or is it very slow when it comes to responding? Next, we need to take a look at the network monitoring part. And although network monitoring sometimes is assumed as a given إن عمر ما هيحصل مشاكل في النتورك بتاعتنا، بس more often rather than expected بنلاقي مشاكل في النتوركس. خليني أشير معاكم a small problem كده حصلت من فترة. كان عندنا سيستم لايف بقاله كتير قوي ولقيت كول الساعة 9 بالليل. خير يا جماعة البورتال واقع ازاي؟ ايه المشكله؟ ما بيفتحش. فايفنتشلي دخلنا على السيرفرز نفسها وجربنا نفتح وانا بنفتح. طيب جريت. الكلام ده ما كانش في مصر، كان كلاينت بره مصر. طيب ايه المشكله؟ ستيل البورتال ما بيفتحش. When we tried opening the portal from a different node يعني مش from the local host لقينا ان فعلا ما بيفتحش. which was really weird لان دخلنا شفنا السي بي يو utilization والميموري utilization لانهم زيرو. مفيش اي مشاكل في الميموري او في اليوتيلايزيشن. After a few hours اكتشفنا ان كانوا عملوا installing الانتروجن ديتكشن سيستم، والانتروجن ديتكشن سيستم واكل كل النتورك، فمخلي النتورك يوتيلايزيشن بتاعتنا through the roof so high to the extent that requests were not arriving. Network monitoring is important and sometimes it can cause catastrophic failure if not handled correctly. last but not least is the infrastructure monitoring. Infrastructure monitoring has to do with the actual machines. بنتكلم في CPU utilization, memory utilization, disk utilizations, and so on. So those are the 4 main components that we need to monitor in order to handle chaos. طيب. In order to achieve this level of monitoring, we need to take a look at the 3 pillars of observability, which are logs, metrics, and traces. Basically عشان اقدر اوفر ال4 items اللي اتكلمت عليهم من شويه اللي هو business monitoring, service monitoring, network, and infrastructure monitoring, I need to use those 3 pillars, which are logs, metrics, and traces, وهنتكلم عليهم بالتفصيل كمان شويه. طيب. تاني معظمنا عارف اللوجز وشايف المنظر اللي على الشمال ده. Okay. والlogs are pretty much the easiest and fastest way to push data outside of your system. Logs are time-stamped and they have context and they have a lot of data. Logs can be in different kinds of formats. مش شرط a plain text، ممكن تبقى structured وممكن تبقى binary. For example في حالة database systems يعني MySQL مثلا اللوج بتاعه is in something called pflog format, which is basically binary data. However, logs are also application scoped only. When I take a look at the logs, I'm looking at the service بتاعتي, service بس. Not anything external or outside the network boundary. Or the memory boundary to be more precise. الحاجة الثانية, logs are very hard to search. How hard could logs be to search? I will share with you برضو another problem that we faced recently. Production system وبقاله I think 3 years or something. شغال وحصل فيه مشكلة we decided to take a look at the logs. اكتشفنا ان اللوجز 12 جيجا بايت. عشان ننقل اللوجز من السيرفر بس ونجيبها عندنا دي كانت ساعات. فاللوجز can grow drastically in size. And the bigger they get to be, the harder they are to search. Next pillar is the metrics. Metrics basically is a numeric representation of the data. This could be a transaction time, number of successful transactions, number of failed transactions, CPU usage. هي في الآخر a single value. However, this single value can be very useful when it comes to projecting system usage or identifying historical trends. Basically, الماتريكس بنستخدمها أكتر عشان نبيلد داشبوردز تورينا السيستم شكله إيه النهارده. For example, a metric could be number of requests processed or number of failed requests. Basically, with those 2 numbers, I can know if my system is operating ولا لا, or if my service is operating ولا لا. ميزة الماتريكس زي ما انتم شايفين انها they are very small in size. Basically, you're looking at 4 pieces of information. How you can store samples as much as we want. And searching through those samples is pretty much easy لأن في الآخر أنا عندي identifier هو الماتريك name والليبلز اللي associated معاها. وبكده هقدر أبني visibility towards the system usage. Okay, how can this be beneficial? For example, لو أنا لقيت إن number of users بتوعي بيزيدوا over time, this means that I will need more hardware resources and more scaling in the near future. وأقدر أحسبها بالتقريب هحتاج قد إيه كمان قد إيه to meet the forecasted scale. Sometimes metrics are useful in identifying the lack of the presence. For example, لو أنا النهارده بفتح المونترنج سولوشن بتاعي ولقيت مفيش ولا ريكوست، ده معناه ان غالبا الابلكيشن مش قايمه، مش ان مفيش حد بيستعملها، معناه ان في drastic catastrophic failure حصل. Actually this was one use case that we used برضو a few months back. فتحنا السولوشن بنبص لقينا مفيش ولا ريكوست جاي، 0 ريكوست. However luckily كانت المشكله على النتورك ليفل مش عندنا. بس at least it's a way to know that there's a problem before your users report the problem. طيب. Last but not least وأهم pillar when we're talking about microservices is tracing, or to be more precise, distributed tracing. Microservice architectures are very strong. However, they suffer from a small challenge. or it's rather a huge challenge, which that they have no in-memory pools or stack trace. ده معناه ان debugging those systems is extremely complex. However, this is where distributed tracing comes in place. If we take a look at these 4 services A, B, C, and D, في النص B بيروح يكلم Redis اللي هو caching server. Let's say ان A يكلم B, B يكلم C وحصل failure في C. If we just rely on logs, there is no way to identify where this failure happened. ليه؟ لأن simply A has no idea of the existence of C or D أصلا. So if we take a look at a more detailed diagram, هنلاقي هنا لو أنا عندي operation طولها 320 ملي سكند، فأنا عندي فيها كذا operation، whether B بيكلم R, C بيكلم D, and so on. What distributed tracing provides is an insight of what each operation did and how long did it take. This can be very useful in anomaly detection, okay, and diagnosing what's happening to our application, or even profiling the resource attributes بتاعتنا and projecting the workloads. For example, through distributed tracing, I can say إن أنا عندي service B, for example, is taking quite a long time due to load, I need to scale service B. أو هقول والله إن service B ما عنديش مشكلة لأنها تاخد وقت فمش هسكيلها ساعتها. However بقى عندي visibility towards كل حاجة في السولوشن بتاعي، كل component بياخد وقت قد إيه، وبياخد وقت قد إيه في كل context. So what's happening to my solution؟ صحينا الصبح لقينا السولوشن وقع، هنعمل إيه؟ Distributed tracing هيجاوب لنا على سؤالين مهمين جدا. أول حاجة الليتنسي، كل سيرفيس خدت وقت قد إيه علشان خاطر تخلص أو تفيل. Finally, the root cause. What's causing the root cause of our problem? If you remember from this diagram, لو R is failing مثلا أو R is timing out، هيبان عندي هنا إن R is timing out، وهيبان عندي إن R هي اللي causing the transaction أو overall transaction to time out. طيب, this is very nice. But how can we achieve this? The first step towards distributed tracing is instrumentation. أي حد اشتغل قبل كده with Java 5, for example, or before Microservices, knows that instrumentation was done manually. We used to put tracers في الكود بتاعنا بين كل function والتانية، كل database call والتانية، عشان خاطر نقدر نمونيتور database call خدت وقت قد إيه. ومشكلة إن الكلام ده كان بيحط overhead على السيستم. و more often than expected كانت حاجات بتقع. For example, ممكن يبقى سطر زي creating a new function or a new object which seems friendly enough. يبقى هو اللي واكل كل CPU usage and there is no way to see it with manual tracers. However, at the end of the day, we need to have tracers and event emitters in our system. Whether you do it manually, whether we do it automated زي ما هنشوف قدام, we need to have a component that collects detailed performance time on incoming requests, database queries, cache hits and misses, external HTTP requests, and so on. And usually, incoming requests and outgoing responses are one of the core things that needs to be instrumented. بالذات لو بنتكلم في solution في financial information أو financial transactions. أو برضه بصراحة لو هتintegrate مع أي external party, it's a good thing to log the incoming requests in raw format. طيب, luckily, we don't have to do it manual anymore. Bearing in mind, in instrumenting your code manually at the middle of the project can be a nightmare. بالذات لو البروجكت كبير. طيب, ايه alternative? Alternative is auto instrumentation. There are plenty of libraries that provide auto instrumentation. أشهرهم Micrometer, which is used by Spring. Spring Actuator, for example, uses Micrometer. Micrometer, one of the benefits of it is it's vendor neutral, which means the data اللي بيطلعها is quite static. Sorry, it's quite standardized. However, you don't have to use Micrometer if you want to use a more sophisticated solution. You have Zipkin, Jaeger, and Elasticsearch. However, nothing really comes for free. For the first second, you would say, well, few options كتيرة قوي, طب I would use any one of them, Zipkin, for example. However, there are challenges with having multiple tracers or tracing systems. To explain why, أول حاجة عندنا tracer is composed of two parts, a tracer runtime with tracing backend. Tracing backend is an interface أو a deployed application بنخش عليه عشان نشوف البرفورمانس بتاع السيرفيس بتاعتنا. مين كلم مين وخد وقت قد ايه and so on. Okay, therefore there are multiple vendors here. التراكر runtime أو tracer runtime هو اللي بيفيد الtracing backend. where it reads from the instrumented code. The challenges are very simple. أول حاجة which tracing system will I use؟ النهاردة أنا عايز tracing system، هختار زبكن ولا ييجر ولا إلك ولا مين and why؟ We will shed some light on which tracing system to use in a few. However, a more important thing or something to note in tracers are embedded in your code. They are part of your application. What happens if you want to change them؟ أنا النهارده بستخدم زبكن، قدام قلت أنا عايز أستخدم ييجر باك إند، شايف إنه بيطلع insights أحسن. Does this mean I need to change my code؟ وbear in mind إن إحنا كده هنبقى بنشينج كود على مايكرو سيرفيسز كتيرة، مش واحدة بس. طيب another thing، افرض إن أنا بكلم a third party provider. third party provider دوت ازاي اقدر انتجريت مع التريسر بتاعه؟ ازاي اقدر افتش التريسنج انفورميشن ديت واستعملها؟ Luckily the solution is simple. او not very simple الصراحه يعني، بس it's standardization. We need to have a standardized way where كل الكومبوننتس بتاعتنا can speak to each other. طيب قبل ما نتكلم على standardization let's take a step back ونبص ايه الكومبوننتس الموجودين في اي ابلكيشن. هنلاقي ان اي ابلكيشن فيها الابلكيشن كود بتاعنا وده اللي هيبقى instrumented، فيها shared libraries and services حاجات third party مش بتاعتنا واخدينها، وفيها external services او ناس ثانيه بنكلمهم. Accordingly the architecture components of a distributed tracing system would be as follows. اول حاجه ال distributed tracing API. ال API اللي هستعمله عشان اكلم التراكرز. اوكي. تاني حاجه ال context definition. النهارده انا عندي service A بتكلم service B, which means that the tracing context should be forward from service A to service B, which could be also an external service. We need to have a standardized tracing context. وفاينلي انا النهارده عندي service A بتكتب في الداتا بتاعتها، بتكتب في التراكر بتاعها. We need to have an interoperable way to exchange data across tracers. ما ينفعش الداتا اللي في تريسر واحد تفضل قاعده جواه ومش قادره تتحرك. مش كده بس، I also need to have an interoperable way to have my service feed more than one tracer. For example, I would like to use my tracer اللي هو elk to feed other tracers such as Zipkin with another system. And last but not least the cornerstone بتاع أي standardization which is the trace data. The trace data definition. لازم الداتا اللي trace تبقى in a definition that can be understood and agreed upon by all vendors. And this is where open tracing comes in place. Open tracing is an initiative with the sole purpose of providing a vendor-neutral API for distributed tracing. Open tracing is a specification, however, it is not official yet. They are trying in a day an official tracing API specification. However, those are still attempts. Nothing is still officialized. Having an open tracing API or complying with the open tracing specification معناه ايه؟ معناه ان انا I will avoid vendor lock-in، ومعناه ان انا I can get a shared library that can provide tracing functionality out of the box with minimal effort. And it will fit directly مع التريسر بتاعي regardless هو ايه. اشهر الناس اللي بتستخدم اوبن تريسنج هم اوبر ويلب. طيب let's take a deeper step towards understanding what is open tracing and what is composed of, or what is the open tracing spec is composed of. Basically, it's composed of three things: trace, spans, and trace context. الtrace basically هو the duration of the transaction or the transaction itself. For example, if a transaction starts with service A and ends with service B, then a trace is basically starting with service A and ends with service B. A trace basically comprises spans. Spans يعني ايه؟ Spans يعني النهارده عندي a logical unit of work عايز اعملها achieving. Let's say for example I'm trying to add a user to a system. Okay, or registering a new user. Registering a new user requires ان انا هكلم system B هزود اليوزر ده فيه برضه. I will start my parent span which basically has a start time and a duration. وهنده على functions جوايا زي مثلا انا اكلم الالداب، اكلم custom database. Okay, each of which هيبقى ليها logs و tags. Tags are basically key value pairs. بيشيلوا اي information انا محتاجها. والlogs, as we explained earlier, are log data. However, logs in this case needs to be structured, preferably in JSON format. They should contain meaningful information. لأن بعد كده I will rely on these logs to build my analytics platform in order to identify problems within the application. Next, we have the trace context. The trace context basically will move from service A to service B. النهارده service B is invoked by service A وفي context. The context بتاعنا in this case هو creating a new user. So the trace context would basically at least contain a trace ID. A trace ID أقدر أربط بيه at different spans ببعض. Finally, when we're done, الtrace هيخلص وبكده هبرزست كل الكلام ده. If we comply with an open standard, what can we expect? Well, we'd expect having different tracer systems زي دولت Elastic APM, Zipkin, Jaeger, or any other system for that matter. And I would have my application code, my shared libraries, my shared services, all feeding each other with zero compatibility issues. At least this is the main target. However, this is a bit far from happening. Today, Open Tracing API provides a standard set of APIs. However, it does not provide standardization for the context definition. أبسط example لو بصينا على Jaeger و Elastic APM هنلاقي إن ال trace ID بتاعهم الفورمات بتاعه is completely different, which means they are not really interoperable formats. الحاجة التانية مفيش يعني Open Tracing does not provide a standardized tracing data definition. It provides some content towards tracing زي tags or logs and so on, and the span definition having it with giving it a specific duration. However, it does not specify any more details. It's not extensible. For example, لو أنا عايز يبقى عندي a more solid structure for reporting هيبقى إزاي؟ وفاينلي ودي أهم حاجة, tracers are not runtime compatible. You really cannot pull data from one tracer and feed it to the other. Until this point, this cannot be achieved. With that said, لما هيحصل مشكلة إيه اللي هيحصل؟ Even if you have tracing in place, we will end up with this: numerous systems, where numerous people meeting in one room trying to find what's going on. كل واحد بص على السيستم بتاعه وبيحاول يعرف what happened. Usually, if you're having a medium-scale microservice solution, you can avoid it. For example, one of the things we use هو ELK. It's one platform and we feed it all tracing information. So if there is some work that needs to be done, on top of this tracing information عشان generate dashboards. otherwise كانت هتبقى موجودة out of the box في السولوشنز التانية. however it's a small cost to pay in order to correlate كل الكلام ده. برضه something very important to mention هو ال tracing correlation. النهارده when I have one request going through multiple spans and multiple services أهم حاجة عندي ال thread ID أو ال trace ID to be more precise. ال trace ID هو الحاجة اللي أنا هربط بيها كل الchain دي لبعضها. Therefore, it's important to take a look at this chain in one solution and in one system. أنا so far اتكلمت على ال tracing بالتفصيل. however ما اتكلمتش ازاي هachieve business monitoring. If you remember, one of the main objectives of handling chaos is business monitoring. إن يعرف اليوزرز بتوعي بيعملوا إيه. How is my system doing? For example, ممكن أبقى عايز أعرف والله أنا عملت transactions بكام ألف لو أنا بعمل system بيترانسفير ماني مثلا. او لو انا باخد فلوس per transaction عايز اعرف انا I generated how much revenue today. او ال ROI بتاع السيستم بتاعي ده شكله ايه. طيب how can we achieve this? This is really a very simple part and yet it could be a bit tricky. One of the easiest ways I found to achieve this is using Elk Stack, Elasticsearch, Logstash, and Kibana. To those of you اللي ما يعرفوش Elk هو basically Elasticsearch, which is a very document-based database that is indexed, is very fast. Logstash هو component بيركب معاها دوره إنه يفتش data سواء بقى من text file، يفتش data من database whatever the source اللي هتديهوله، ويحول فورمات Elasticsearch يقدر يفهمه which is basically JSON format. وفاينلي كيبانا هو اليو اي بتاع Elasticsearch، وده اللي عليه بنقدر نبني داشبوردز وريبورتس and so on in a simple manner, in a drag and drop manner. So how can we utilize this to provide insights? أول حاجة لازم تبقى اللوجز بتاعتنا standardized. Standardized يعني إيه؟ يعني they have to be in a structured manner, where they should have timestamps and they should have correlation IDs. Basically they should confirm لكل ال tracing standards اللي اتكلمنا عليها من شوية. تاني حاجة اللوجز مش هينفع يبقى فيها I'm here و I passed function A والكلام اللي كنا بنعمله زمان. The logs has to be meaningful, they have to be rich, they have to contain solid data that's used by your application. طيب, how do we achieve this? The simplest way I found is to transform all your logs into JSON. If we're talking about Spring, في حاجة اسمها Logstash Logback. Logstash Logback هي library that connects gracefully with Spring. We transform all your logs into JSON format. With having your logs in JSON format, you can use Logstash or Fluent, أي tool تقرا من اللوج file بتاعك, and you feed it to Elasticsearch. And through this, you can build your own dashboard in a seemingly manner, in a seamless manner. طيب, في options ثانية غير Elk? Yes, يمكن not for business insight as far as I know. However, for distributed tracing, there are numerous players here. Zipkin, Jaeger, Prometheus, وElk APM. Those are the main players في الاريا بتاعت distributed tracing and providing spans and identifying how is your system behaving. Spring Boot Actuator is not really a distributed tracing solution. However, it's a very good approach لو انت عايز تعرف السيرفيس بتاعتك الهيلث بتاعها شكله ايه، الفورمز بتاعها شكله ايه. if you have a small microservice solution with a bunch of microservices, let's say less than 10, and for some reason you cannot afford to have a distributed tracing solution, then Spring Actuator is the way to go. It uses micrometer عشان يلم data من جوه الابلكيشن, و provides a very nice JSON-based interface or REST-based interface that will tell you your health, performance, bottlenecks, and so on. طيب, Spring Boot aside, which one would you choose? Zipkin, Jaeger, Elasticsearch, Prometheus? Prometheus also isn't really for distributed tracing as much as it's for monitoring your infrastructure. اليوز كيسز بتاعته هي اكتر towards monitoring الكوبرنيتس infrastructure والنودز والسي بي utilization والكلام ده. Choose a time series database in order to collect this information. But anyway, it can still be used برضه لو انا عايز استخدمه for distributed tracing. So back to our main question, which library should I use? Should I use Zipkin, Jaeger, Elasticsearch? There is no really short answer for this question. However, أول حاجة هتبص عليها ال compatibility مع ال open tracing standards. Is the data compatible with open tracing or not? Can data be imported by other systems or not, and exported to other systems or not? The first thing is interoperability. Second thing is the availability of officially supported clients for your language. Basically, tracers دول بيprovidوا instrumentation out of the box. In order to work clients as well. So you have to find clients that meet your language. Whether it's Go, Node, .NET, Java, whatever. Where you should always look for something that is not community delivered, that is officially supported. بعد كده هنبص على الفيتشرز بتاعت الستاك او بتاعت السولوشن. مين بيدي ديتيلز اكتر، مين بيدي داشبورد اكبر، مين اكستندبل اكبر وفي كاستمايزيشن ليفل اكتر. Personally, I would always go with Elasticsearch. بالذات ان انا I can collect data from different data sources. And also I can provide business insights جواه فيبقى one solution fits all. However, really it's about your business use case. Which one would you like to have is really up to you. To conclude, basically with observability in place, you can provide forecasting, anomaly detection. نقدر نعرف والله what's happening. السيستم بتاعنا بطل بقى فيه spikes مرة واحدة ليه، بقى فيه slowness مرة واحدة ليه، كل الكلام دوت. And moreover, you can add alerts لما يبقى فيه slowness أو يبقى فيه performance issues أو constant failures. We can have full text search within our logs لأن our logs كلها بقت في مكان واحد وقادرين نقدر نسيرش عليها in a structured manner. We can أهم حاجة طبعا الروت cause indication. أنا أهم حاجة عندي أعرف في الآخر why this slowness. How can I do this? Because I can simply correlate different log events through the trace ID and through timestamps. فأنا ممكن أعرف والله a span that started from 540 and ended 541 with this trace ID covered which logs. ومن هنا أقدر أشوف اللوجز بتاعتي وأعرف إيه اللي حصل بالظبط at any moment in time. Moreover, it provides you with geospatial analysis. One of the nice things is if you're logging IP addresses, you can provide or you can have a very nice graphical overview of where your requests are originating. فين في العالم أو فين في البلد. To conclude, microservice architectures are complex. That's why constant monitoring is required. However, constant monitoring without tracing data standardization is going to fail on the long term and is vendor lock. So therefore, you need tracing data standardization. It's not optional anymore, it's a necessity. Your logs should be structured. ما ينفعش اللوجز تبقى مش structured، ما ينفعش اللوجز تبقى شايله information ملهاش لازمه. Having a microservice solution with hundreds of microservices means that you need a central place to aggregate your logs. ما ينفعش تبقى كل log موجود في كل service. There has to be one place شايل كل information ديت and you can view it from this place and you can correlate it together. And finally, to avoid chaos, we need to implement proactive monitoring. That's it. Any questions?